All right, let's dive right in. Today, we're heading out to sea, into the wild world of offshore wind farms. We're talking about some of the most massive, most ambitious renewable energy projects on the planet. But how do you even begin to build them? We're going to look at the huge challenges and the incredible tech that's making it all happen. This quote really paints the picture, doesn't it? Just imagine that for a second. You're there, feeling that sea breeze. But what's really amazing is what's happening just over the horizon. There is a quiet revolution going on out there, a new kind of power that could literally change our future. And this is it. This is that new frontier. We're not just talking about a few windmills. We're talking about colossal structures, absolute giants standing tall against the waves, built to capture the raw, relentless power of the wind at sea. The potential for energy here is, well, it's immense. A total game changer. Okay, but here's the reality check. Building these giants out in the middle of the ocean, it is one of the toughest engineering puzzles we've ever tried to solve. And believe me, it's not as simple as just sticking a regular turbine on a barge and calling it a day. The ocean, it does not play nice. So first, you've got the environment itself. I mean, think about it. You've got constant corrosive salt spray eating away at everything. You've got the crushing force of massive waves. And just the logistics of building and maintaining this stuff miles from land, it's a nightmare. It is a constant 24/7 battle against the elements. And then there's the wind, the very thing we're trying to capture. Out at sea, it's not some gentle, predictable breeze. It's chaotic, it's powerful, it's totally unpredictable. So designing turbines that can not only survive these conditions, but actually work efficiently, that requires a whole different level of thinking. And here's a problem you might not even think about. It's fascinating, really. When you pack these giant turbines together into a farm, they start to mess with each other. The wake, the choppy air coming off the blades of one turbine, can totally disrupt the airflow for the turbine behind it. That creates all this weird turbulence, and boom, your whole farm suddenly gets way less efficient. So you've got this whole list of seemingly impossible challenges. How on earth do we get past them? Well, this is where the hero of our story comes in. It's a piece of software called QBlade, and it is completely changing the game for how we design these incredible wind systems. So what exactly is QBlade? Honestly, don't just think of it as a tool. It's more like a strategic partner for engineers. It's this super advanced simulation platform that lets them build, model, and stress test their designs in a completely virtual world long before a single bolt is tightened or a single piece of steel gets wet. So how does it actually work? How does this digital platform let engineers stare down these impossible scenarios and, actually solve them? It really boils down to three key things. First, it can create a perfect digital simulation of that harsh, dynamic ocean we were just talking about. Waves, wind, everything. Second, it can model those super complex aerodynamic interactions between all the different rotors. And third, and this is the magic part, it takes all that data and helps engineers figure out the absolute perfect layout for the entire farm, squeezing every last drop of energy out of the wind. Now, this is what really shows you the massive shift that's happening. The old way? You'd have to build incredibly expensive, full-scale physical prototypes, which took years. With QBlade's virtual testing, the cost just plummets. Development time shrinks from years down to, days or weeks of rapid-fire testing. And the accuracy of the predictions, it's just through the roof. This isn't just a small step forward. It's a completely different way of doing things. And having this kind of powerful simulation tool in your back pocket, it unlocks an even more exciting future. We're moving beyond just designing better turbines. We're stepping into an era of truly intelligent, self-managing energy systems. And the key to all of this is a concept called the digital twin. Okay, imagine this. It's like having a perfect one-to-one virtual copy of the entire wind farm running on a computer, like the most advanced video game you've ever seen. This digital copy gets fed live, real-time data from the actual turbines out in the ocean. This lets engineers test scenarios, predict when a part might fail, and constantly tweak the operations for peak performance, all with zero real-world risk. And this is the result. This is what you get. You get intelligent turbines. They're monitoring their own health in real time. They can literally schedule their own maintenance before something breaks. They can automatically adjust themselves to changing winds to be more efficient. And the bottom line? More clean energy and lower costs. It's a win-win. So all of this leads us to one final really big question. As these simulation tools get more and more powerful, we're getting closer to a point where we can pretty much perfect a design in the digital world before building it in the real one. So when we can simulate reality that perfectly, what's next for clean energy? What other impossible problems are we going to solve? It's an incredible time to be alive, and technology like QBlade is showing us the way.